Right, okay, so we're going to just do a quick refresher for those of you that weren't here last time with your pretend sickness on these diagrams, because I know Matthew's Tamar very good at these anyway, so we've got a couple just to go through. So we've got a diagram. We were looking at stating what fraction of the shape is shaded. Alright, so would you like to explain to me how you would do that, Thomas? So, do you know, if you want to just tell me the answer, but then explain how you got the answer.
I'm not sure.
Not sure, okay. Magnus?
So, the A is 3/4.
A is 3/4.
So 3/4.
Why?
Because you can see the two lines going across.
Yeah.
And there are 4 triangles.
Yeah. So the whole shape
And
has been split into 1, 2, 3, 4 identifiable parts.
3 is shaded. So
Yeah.
that gives you an answer right away.
Yeah. So the thing is, there are lots of different ways. So we could look at how many little squares there are. All right. But we can also just identify that it's been split into 4 bigger groups. Alright? So 4 big sections, 3 of those sections have been shaded. So the other way would be to be saying, well, there are 36 squares, and if we were to count how many have been shaded, okay, we would count that 27 out of the 36 squares have been shaded.
Yeah.
Right? But that's easier because they're halves, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 in each triangle. So 3 lots of 9 shaded makes 27. So there are 2 ways to do it. Either way is correct. So, this one then, Thomas. What's the shape been broken up into to start with?
It's been broken up into quarters, kind of.
So that would be saying that there are 4 sections.
4 sections.
8.
You would say 8. Why?
Because there's 6 lines and I count 8.
Yeah, so there's 1, 2, 3, 4, 5, 6, 7, 8 sections.
3 over 8.
So it's 3 out of the 8 sections. Okay? Or there are 2, 4, 6, 8 by 6. 8 by 6 is 48 squares. And there are 1, 2, 3, 4, 5, 6. So 18 out of 48 little squares have been shaded. So either way, that's fine.
So you could write down any of them in a question.
Yeah. So this one would be simplest form. This would be an equivalent fraction, which is what we're going to be looking at today actually, equivalent fractions. So it's different numbers, but they are the same fraction. Okay? Got that?
Yep.
This one then.
That's more harder.
Yeah.
So we look at what it's been broken up into, and we think, oh, maybe it's squares, but we've got one here. So actually what we've got is 1 triangle, and then 2, 3, 4, 5, 6, 7. So we've got 7 out of.
I can count 1, 2, 3,
1,
4, 5,
2, 3, 4, 5, 6, 7, 8,
18,
15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
25.
7 out of 25. Okay?
Okay.
Yeah?
Yeah.
Makes sense?
What's the other method? Like,
Is that the only one for that one?
Yeah.
Well, no, obviously we could still count the little squares.
Can we not do that?
No.
Oh, Jesus, can we?
No, we won't bother. But as long as you realise we could.
You
But
could
the whole point-
actually, because you know on the sides there's like half of a square.
Yeah.
If you can count all of them up.
So
like,
actually,
by making
each little triangle is how many squares?
about
1 and 2 halves
two
make
halves.
2. So each little thing is 2.
Two.
So actually,
one,
how many
two-
little squares are there in total?
Wait,
There are
including the shaded.
50 little squares in total. And the reason why I know that is because it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10 would be a square,
Square.
which would have 100.
100.
We've only got half of it, so it must be
50.
50. Okay? And then we count how many squares, so that's actually quite easy this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 2 halves makes 14.
14.
So 14 out of the 50 little squares. Is that the same as 7 over 25? Yeah?
Yep.
Do you know how to show that,
Yep.
Thomas?
Of course, half of 14 is 7, half of 50 is 25.
Exactly. So that's what we do. If we divide it by 2, if that is also divided by 2, this is what we would say, and again what we're going to talk about today, equivalent fractions. Alright? So let's go through these final ones just a bit quicker. What's the shape, Matthias, that's been repeated?
Squares.
The squares. So
Square.
that would be 1 square, yeah?
Yeah.
So we've got
1,
1, 2, 3, 4, 5, 6, 7, 8. So 8 out of how many?
out of
1,
wait,
5,
20.
4, 20. Good. 8 out of 20. Okay. This one.
it's just 4 by
So 1,
1, 2 by
2, 3.
3 out of 7.
3 out of
7.
3 out of
7.
10.
10.
10.
What?
Oh.
Yeah.
You've just counted the one.
Oh, yeah, I
Don't
just
forget you've got
counted
to
the
count
white
all of them.
Oh,
Yeah?
yeah.
It's 3 out of, or 5, 6, 7, 8, 9, 10. Okay, 3 out of 10. This one,
Oh,
so
geez.
the shape is
It's a triangle.
triangle, so I've got 1,
5 out of
2,
9.
3, 4,
5 out of 9.
5. And then there are another 4, so it must be
9.
9 in
9
total.
in total.
Okay?
Okay.
Right.
Oh, whoa. We have to draw in?
Okay.
On each diagram, shade the fractions stated.
Yeah. So, I think this should work. Why is it not? Alright. My computer.
Oh, basics.
Okay. You think it's
2 hours.
right, guys? So, we've got these questions just to check again. You're going to come and do it on the board. Maybe you can do one each. So, with these shapes, you've got to decide what you're going to shade to make it 2/3 shaded. So, we've got it
Can we do it as a
selected.
team?
So, all you're going to, I'll do the first one with you. That actually, let's just
No, but
check.
it's really easy.
Let's just check. Yeah, we've got enough. The first one then, if I do it for you, so we know that if it's 2/3, we've got to first of all break the shape into
3s.
threes. So for me, the way I've spotted is I'm just going to break it like 1 and 2, 3 like that. Then if I want to shade
In 2
two of them,
sections.
okay. So
Oh, that's basics.
shade.
Oh, I was like, what?
Okay, it is quite basic.
Oh, I can see the next one.
Okay, go on then, you do the next one.
I can do this. Can I draw the line? Like,
Yeah, you draw the line if you wish, yeah.
which
So,
one is that?
This is the line, so if you just draw the lines now.
Isn't it like, so if you half it,
Wait till we get to the
and then down here, and then
But now you've split it into 4 parts. How many parts do you need? to split it?
oh, you need 5!
Yeah, you need 5. So let me undo that. Right, so now you need 5. 5 parts. So I think.
It's so easy.
Continue to do it if he finds it really easy.
Maybe you need to do this
Should I just do it?
It's,
one. No.
I can't.
It's funny.
Well, I see it.
Yes. No.
Along there.
No, Tom.
Wait,
Right, the
one,
thing is, you can't. Go on, carry on.
two. Wait, 1, 2. Oh,
Well,
look at that.
keep going, keep going.
1, 2, 3, 4, 5, 6.
Can I just show you?
Chill out.
If you remove one of the lines.
Okay, well,
That
what
kind of
if
makes-
I get rid of this one?
Oh, no!
Alright, alright.
We could just do it from here.
Okay, so what you did was
One there,
one there,
one there,
one there. That makes 2.
2.
If we hadn't cut it across, if we did another one,
1, 2, 3, 4. Oh, I'm so dumb.
okay. So now you need to shade in the.
1, 2, 3, 4.
Okay.
You missed out on one.
No, you didn't. I thought you said this was easy, Taylor. Is that alright? 5 parts, and 4 of them have been shaded in. Alright.
Come on,
You know what to do, Mattis?
That's coming here.
Matt.
This
It's
one's
okay.
right. This one's kind of been done for you.
Yeah, you just look at the
I
black.
can already see it. I can already see it.
Yeah, we can all see it, Timor. 1, 2.
4.
Yeah, there we go. 1, 2, 3.
Oh no, wait.
Ah, no, you've done too much there, haven't you?
No.
There's a line across.
You have to do a line.
Yeah, I think you've forgotten. Because you've not split it into 8 parts. And now it's
Yeah.
in 8 parts.
And then,
Okay.
yeah.
Okay, good. So just, so yeah, you have split it into, it's kind of there on the diagram. And yes, you're not very good at your shading, guys. You're not really into it, are you? Alright,
Well,
so
And I got a 7 for art.
it's like this.
Good luck. You might fail, but
Oh yes, I want to do F.
Oh, gosh, I want to do that.
It's easy. It's done for you.
What about?
So there's 7.
I think you should.
So actually, it's the first step. Some people see it really quickly.
Yeah, but what happens to me? I can.
Oh no, whoops.
Draw the lines first.
Okay,
Me, what I can do.
so 1, 2, 3, 4. I want this one going
Yeah.
away.
1,
1, 2, 3, 4, 5, 6, 7.
8, 9, 10. If you continue
Just draw all the lines. Split
Okay,
it
yeah.
completely up. Yeah. Don't-
if you can do it the way you
All
were
the lines.
thinking of it, yeah, continue that and then half that.
No.
No, don't you dare to release your finger.
No,
stop. Alright, done. Right, now
Yeah. Okay, my mistake. 10.
1, 2,
go. So we should really complete that.
Oh
right?
yes.
and then
Okay.
just half it.
Yes.
Yeah. So we have to go across, yeah?
Yeah.
Okay.
So-
So now
Yes.
you need to shade in.
You, Table, it's not nice to criticize
I didn't
people
criticize
about
you.
them.
I'm just saying.
Construction.
I'm just
You
saying.
kind of are.
Yeah, you're like Thomas
about it,
Practice, you're so dumb.
I didn't know. I said that was so easy.
Some people can see it.
I can't. I'm counting.
Oh, so dumb. I'm not criticizing you, but you're just dumb. Oh, yeah!
1, 2, 3,
Ow.
5, 6.
6.
You're criticizing me now.
Oh, yeah.
Well, they
It's
are
fine,
kind of
got mixed up.
criticising you for criticising other people. So
I got the lines mixed
okay,
up.
it's your go then.
Me?
Right, if you fail
Either
this...
one or the other. You pick.
You're so dumb.
This is gonna be messed up. He's so tall, I can't even see what he's doing. Oh, jeez.
Wait. Oh, come on, so mean.
So mean.
It's quite messy as well.
Yeah, I do admit. Compared to us.
The other side you can't see.
That's actually not.
Eiffel Tower's here.
Because he cut off some parts with his line.
What was he doing with his other hand?
Okay, are we happy?
He's got it.
Yeah?
Alright,
Yes,
okay.
I got it.
And finally, I think it's already been split.
Yeah, it's pretty
Okay,
obvious.
1.
2.
And then, what do we have?
And there's a line going straight down.
Yeah. And then there's 3. 1, 2. And then you just shade in 2.
Shading 2 of them. Right. Can it be there and there?
Sure.
That's alright, it could be anywhere, can't it?
Yeah, it could be.
Okay, guys. So,
Basic.
you get the idea. Do you remember what this number was called?
The
Dominator.
Denominator.
The
Almost.
Dominator.
Almost.
Numerator.
No.
Oh, come on.
Dominator. No.
I know it's a nominator. I think.
Denominator.
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 I
Okay.
busted.
Now, the denominator is important, as we've said, because it's the number that you split the whole thing up into. Right, now I just want to go back to what we were working on, which was this stuff, which is,
Hello.
right, remember we were talking equivalent fractions. Equivalent fractions. So actually, you can split one thing up, like our grid here, into big pieces or smaller pieces, and if you want to keep the same amount, so for instance, like I have here, I have a cake.
Oh. Don't push it.
Now, if this was my cake, if B was my cake, there'd be two things that would be done here, right? I could cut it into only 8 pieces. Right.
So there's 8.
Or I could cut it into
16.
16 pieces, or I could cut it into 48 pieces, or so on. Okay? Now, if I cut it into all those amount of pieces, I could keep the same amount of cake, but the more pieces I cut the cake into to start with, the more of those pieces I have to take to keep the same amount of cake. Does that make sense? So, for instance, if I cut it into 8 pieces, I have to take 3 of them. But if I cut the cake into 48 pieces, I have to take 18 pieces to keep the same amount of cake. Yeah, make sense? So that's where we have...
So, yeah.
Yeah, go on.
Yeah. So you're basically cutting it all into 48 pieces. So
Yeah.
basically you're cutting it in half, but then.
Well, not quite. So,
No,
for
you're cutting it in
instance,
pieces.
if I look at this one, the 3/8 into 18 over 48, each piece has been cut into how many pieces itself?
48.
48.
No. Each little piece.
Oh, little piece.
So if I say this was one piece, but
You cut it into little pieces.
how many little pieces is that
6.
one? 6. Okay. So this is how I found my equivalent fraction. So my 3 pieces, each one has been cut into 6 pieces. So I times it by 6.
8.
Therefore, they all got cut into 6 pieces. So that's how I do it. So it's like all of them get chopped up.
So if 8 pieces get chopped up into 6 little pieces, you end up with 48.
Yes. So every single one of the 8 all gets chopped into 6. So
Oh.
for instance, that's how we would find an equivalent fraction. So this one, for instance, we've taken 8 out of 20 pieces. But each little square has been cut
4.
into 4. So the equivalent fraction here would be times 4, which would make
That
32.
will make 42.
32.
32.
20 would also, all of them get cut into 4. So actually it would be
80.
80. Okay? So that is an equivalent fraction. 8 and 20 would be. But what if I only chopped it into each piece into 2?
Times 2.
So times 2.
16.
So we'd end up
So
with
16
and
and
40.
40.
Yeah.
Oh, and then when you times it by 1, it just ends up into 8 pieces.
I have a question.
Yeah.
That makes sense.
So at 8, and then there's the average of 32.
Yeah.
Why is it times 2 and then there's
It's
1?
not. It's times 4.
Oh, okay.
That's why when I
Sorry.
said times 4, you need to be awake with me.
Oh, sorry.
My writing is sometimes not the best. Okay, so did you get the idea of equivalent fractions? So
Yes.
what we're going to do, alright, your objective, can you write this down? Be able to state an equivalent fraction. Right guys, let's just go through this just quickly. So we've already been talking on it, but we want to be able to state an equivalent fraction. So with a fraction, we have a numerator and the denominator.
So that's the top.
And what we do, if we multiply by the same amount, okay, so let's, so I'm going to call it a k, multiplied by the same amount, top and bottom, I get an equivalent fraction.
We did that last year.
Yeah.
Do you know the word equivalent?
But the same. The same.
Yeah, same. So it's
Equal.
basically, equal's a better word. They are equal in value. They're not the same, although if you put that amount of cake, you would have the same amount of cake. But it's different numbers, but they are equal to each other.
But doesn't the line so say 3 and 10, the line in the middle means divide.
Yes. So what we're saying is, you're very correct. 3 divided by 10.
Yeah.
Okay, is what we would say. But as an equivalent fraction, can you tell me any equivalent fraction you like?
To
To 3 over 3
3
10.
over, is it so 6 and 20.
Yes,
20.
because it's
double.
times 2 times 2. Can you think of another one?
Yes. 12 and 40.
12 and 4. Now, I was expecting you to say that because what you've done is just times 2 again. Now, there is an equivalent fraction in between because we forgot to times by 3.
Oh, because it's 3 times.
So it could have been
9
9
over
over 30.
30. So really, this one would fit into here.
Yeah.
Now, I'm going to take you back to what you said, Thomas, because it's actually a very intelligent thing you just said. 3 over 10 is a division. So 3 divided by 10 is what? Do you remember?
3 divided by 10 is.
Good test.
Oh, I've got it.
3.
Do you remember how to divide or multiply by 10?
3.5.
No.
Oh, we forgot this.
0.3.
0.3, yes.
0.3.
0.3. Remember doing that? Just divide by 10, you move the number
No,
back.
I thought you meant.
Oh, yeah. You
No,
move
I
that.
thought you meant like 10 divided by.
No, you didn't. Stop trying to
So much to pass it.
3 right, now here's the thing. How much do you understand? So, if 3 divided by 10 is 0.3, what is 6 divided by 20?
Okay, that's what it is.
Is it 0.3?
Well done, Magnus. What is
Oh.
12 divided by 40?
0.3.
0.3. What is 9 divided by 30?
0.3.
That's because they're all equivalent.
Yeah.
So that is how we can use fractions to help us do a division, for instance.
Cool.
Yeah. Because it's easy, I think, to divide by 10, so you can get an equivalent fraction. So that's a very useful thing. So we can say we're using equivalent fractions to divide. So there is a reason for doing it. Alright? Do you want to make your notes? Okay guys, so we've got our equivalent fractions. So we've seen how we can use it for division. Let's just quickly, so back to our diagrams. These are the questions that I want you to do in your book, but
Let's see.
it's quite easy. Let's go through them together now. So the diagrams show 2/5 is equivalent to 4/10.
Yeah.
How do they show that? Could you explain that? So 2/5 is equivalent to 4/10 because we know we
2 times.
times 2
2.
and times 2. So how is it shown in the diagram though? Explain. Go on, how is it 2/5? This one we'll say is 2/5. This one is 4/10.
I know.
How do we show it? Magnus?
Well, the little squares, you count 4 little squares.
So which one are you talking about? The 4/10 or the 2/5?
The 2/5.
Okay.
So
Yeah.
the 2/5
Yeah.
Wait. I know it's just so the 2 Oh no.
Yeah, I think
I know,
by
I know
doing
it.
that with your fingers, I think I know what you're saying.
Yeah, I know.
Tamar, add to it. Add to them. Help them.
It has on the 2/5. If you look at the bottom line, it has. If you take 1, it has 1,
So we've
like-
got 1,
2,
2,
Yeah.
3,
4.
4, 5.
So there are 5 columns.
Yes,
Yeah.
that's what I mean.
5 columns.
And then on the other
we've
one,
shaded
2.
2 of them. That's why it's 2 out of 5. So we ignore the other lines.
so basically what they did, they just put a line through the middle on the other one. So
Okay.
that's double.
Yeah. So
You
we
can actually
have.
see the line.
Yeah. So we've got the columns like you said. So 5 columns. So as we said, times in by 2 actually
You just
splits it into
2 bits.
smaller bits.
But what if you times it by
So now
3?
it's 1, 2, 3, 4 out of 10.
But what
Right?
if you times
Yeah,
it by
if you times it by 3, it would be 6 out of 15. Now the trouble is,
How would you draw?
how would you draw it is a good question. It wouldn't work quite as well, would it? We'd have to split it into 3. So instead of, so we've got that split into 3, we'd actually have to do something like split it there and split it there.
Oh, so you split it through the
So it wouldn't be
square.
very nice. But we could see it's 1, 2, 3, 4, 5, 6 out
Also-
of 15.
This
Let's
is-
go on.
when you say times, so 2 times 4, and then but if you're timesing by 3, you won't times the 4 by 3.
No,
you times the 2
Back to the 2, yes.
Okay.
So it's that times 3.
Okay.
Right, we'll have a look at question 2 next time. Okay?
Okay.
Done.
Alright.